So, welcome to this video. This one's going to look at really important is that we don't just carry on going on, we keep coming back. So actually, just a little revision activity for you here. There are a number here of anagrams. These are all words that we've covered in the last couple of lessons. What I want you to do is, in a second, pause the video, see how many of these you can actually work out what they are, and not just what the words are, what actually does that word mean? What is a clear riff or whatever the anagram of that is? So pause the video, okay, stop, give yourself 2 or 3 minutes, at least, well, 5 if you can. How many of those can you work out? Okay, and what do they actually mean? Okay, and just a word of warning, that doesn't mean it's 2 words, it just means that it's got 8 letters in. It could be more than 1 word, it could be less than that. Okay, right. So pause the video. Let's see how you get on. Okay, so let's see how you've got on. So Cliver Riff. Okay, hopefully you got that one. Is a river cliff, and a river cliff, remember, is found on the outside of a meander. It's where the fast water is eroding, and it's causing a little mini sort of cliff on the side of a river, which is why we call it a river cliff. Right, next, a dema. Okay, and again, that's a meander, that's a bend in the river. And remember, when you get bend in the river, you get erosion on the outside and you get deposition on the inside. Perhaps my favourite one, Poles Floppif. And if you have a look at that and you rearrange it, you should end up with slip-off slope. And slip-off slope is, I call it a river beach. It's sometimes known as a point bar, a slip-off slope, a river beach, but it's what forms on the inside of meander where you've got depositions, you've got sand and rocks building up. Okay, and I always, like I say, I tend to call it a river beach because it's easier to remember, but the exact technical term is probably a slip-off slope. Then we've got a wake block-zoe, and a wake block-zoe is an oxbow lake. And that, remember, is an old meander. The river has basically cut it off and is going a different way now. Right, next we've got Cloudremis. And I have to be honest, off the top of my head, I can't work that one out myself, so good luck if you have. And in fact, oh, it's the middle course. That makes perfect sense. And that is, as the name suggests, the middle part of the river. It's coming out of the mountains and the hills. It's still fairly steep. And that's where the sort of river starts to meander for the first time. Right, then we've got Toffslaw. And again, that one is fast flow. And that's what you're going to find on the outside of a meander. Remember, the outside of meander is fast, the inside of meander is slow. I'm guessing, yep, that wow foals is slow foal. And again, that's what's going to be found on the inside of a meander. Onisol sounds quite painful, but in fact is erosion. And that's the wearing away of the land. That's where the force of the water is banging and smashing and breaking bits off. And the last bit, Neutstopped, is deposition. And that occurs when the water is much slower and actually it's got less energy. And because it's got less energy, it has to drop things and then you get deposition. So make sure you are happy, even if you can't do the anagrams, okay, make sure before you do anything else, you know what each of those terms means. If that means going back over and listening to me doing it again, writing a glossary, doesn't matter, you need to know those terms. Right, well, hopefully you do know those terms. Let's go back to what we're going to do today. So it's about weathering and mass movement. So let's have a look, first of all, at where this fits into the course so far. So we've sort of done it in this sort of thing. We start off with river processes, things like erosion, transportation, deposition, siltation, abrasion, all of those sort of things. Then we started looking at the upper course and we started looking at things like waterfalls and V-shaped valleys. We've more recently looked at the middle course and meanders. Last lesson we started looking at the lower course. We looked at things like levees and estuaries. And now we're coming to the final bit of this unit, looking at rivers. And these are river processes, and that's other processes. So these are processes not part of the river, say, but happening next to it and important in understanding the features it forms. Okay, so what are we actually going to look at? Well, we're going to look at mass movement first. And that's basically, mass movement is stuff falling down a hill. And there are 4 things we need to look at: rockfall, mud flows, landslip, and soil creep. And the nice thing about them is that the name suggests what they are. Rockfalls is rocks falling down, mud flows is mud flowing down the hill, soil creep is the creep of the soil. And then weathering processes, we need to look at biological, chemical, and physical. And what you need to know for each of these is how they happen, how they contribute to river processes, and when they're more or less likely to happen. So let's start with mass movement and let's get cracking. Now, as we said, there are 4 different types of mass movement, and you also need to know the definition. And I think in a second there's a worksheet where you're going to have to remember that definition. It's basically the movement of material downhill by gravity. And what we'll do now is we'll just watch a little video that explains those in a bit more detail.
Created using Powtoon.
Okay, well, I hope that helped explain what we mean by the different types of mass movement. Now, you should have this worksheet, and what you'll see with this worksheet, you've got a number of words at the top, and there's a number of missing gaps. There's also some nice diagrams here as well, so they can help you as well understand the 4 different types of things that are going on. All you need to do is put in the right word in the right place. Should be fairly straightforward. If you get stuck, the answers are on the next slide. But what I want to do now is stop the video, have a go at the worksheet, and when you've got as much as it done as you can, press play and we'll go through the answers. Okay, so let's go through the answers. So it starts off with different mass movements occur on something under different conditions, and it's going to be on slope. You can't have mass movement unless there's a slope. And as you can see, we're going to look at 4 different types: rockfall, mudflow, landslips, and soil creep. Okay, so rockfall. Okay, so rockfall is the rapid freefall of rocks down a steep cliff. It's basically rocks falling off a cliff. Okay, fragments fall to the face of the cliff because the action of gravity. And remember, all of these are driven by gravity. It's made worse by freeze-fall. Now we'll look at that in a bit. Okay, the type of weathering which loosens the rock. Bare, well-jointed rock is very vulnerable to rockfall. Water enters the joint, freezes and expands, and that's why that process is called freeze-fall, and we'll talk about that in a second. Cracking the rock, scree slope is formed at the bottom, and that's just basically a pile of bits of rock, and that forms at the bottom of the cliff. So that's when solid rock falls down, and then sort of the opposite of that, if you like, is what's called a mud flow. Okay, and mud flows occur on steep slopes over 10 degrees. Again, if it's not 10 degrees, it can't be a mud flow. Interesting, if it gets much higher, sort of 50, 60 degrees, you won't get a mud flow either because the mud won't be able to build up. So 10 degrees is about 10, 20 degrees about the optimum. A rapid sudden movement which occurs over a period of heavy, what's mud? This is when the soils turn to mud, so it's going to be rain. When there's not enough vegetation to hold the soil in place, saturated soil flows over impermeable subsoil. What does that mean? So basically, you've got impermeable means it can't absorb water. So the top layer of soil gets absolutely soaked. Okay, that's what we mean by saturated. It turns to mud and it flows over there. And that can cause great devastation and endanger lives. And there have been examples where it's killed hundreds, if not thousands of people. So it can be really nasty. Okay, the third one is a landslip. The most common type of these are sort of, and what that diagram is showing, something called rotational slumping. But it's basically when the land sort of slips down, but it stays as one solid lump. So it's not a rock, it's not a load of mud, it's like a solid lump of ground. And let's go through the answers here. There are occasional rapid movements of a mass of earth or rock sliding along a concave plane, that means like a curve. Okay, occur after periods of heavy rain when the water saturates overlying rock, making it heavy and liable to slide. And then undercutting a steep slope by river or coastal erosion weakens the rock above, making slump likely. So if you sort of erode the bottom, then what will happen is the top will slide down. And then our final one, soil creep. Okay, as the name suggests, it's creep. So this is a very slow movement. Okay, forms on gentle slopes, and basically it happens because soil expands and contracts, and that happens during wet and dry periods. In wet periods, the soil, the clay particularly absorbs water and expands. In dry periods, it dries out and shrinks. Okay, and as we just said, when the soil dries out, okay, it contracts, and as a result, the soil slowly moves down slope. There are 4 different types of mass movement. Okay, so moving on, we need to look at weathering. Now, weathering again is basically rocks being broken down in situ. It's not like erosion. Erosion is something forceful and moving and smacking and crashing into it. This is it just crumbling, slowing down. To help you get the idea, you can listen to this sort of geography song, which I will leave to you, and I'll come back to it after.
When rock will break up in pieces and become smaller now, if they remain simply breaking down. Weathering when water freezes and thaws in the springtime, it splits rocks in two. And it's ice in cold December, but water when it becomes warm. And rocks broken, they're expanding, and seeps and fissures in the holes that freezes on. Now, start with the chunk of lava and rock. It's weathering when it's breaking down. Mechanical and chemical, biotic rocks are smaller now. Movement of rocks, taking some time. Erosion rocks moving aside. And now that all the force is done, by water wind they travel now. It can be chemical reactions, breaking down bonds. Them fall apart. Oxidation, carbonation, hydrolysis, rocks are soft, helping to break them all apart. But some of the force start with the chunk of lava and rock. It's weathering when it's breaking down. Mechanical and chemical, biotic rocks are smaller now. Movement of rocks, taking some time. Erosion rocks moving aside. And now that all the force is done, by water wind they travel now. The roots go down. The rocks are cracking and breaking. They wedge it wide in space they make. And it's ice in a cold December, but water when it becomes warm. And rocks broken, they're expanding, and seeps and fissures in the holes that freezes on. Now, start with the chunk of lava and rock. It's weathering when it's breaking down. Mechanical and chemical, biotic rocks are smaller now. Movement of rocks, taking some time. Erosion rocks moving aside. And now that all the force is done, by water wind they travel now. Start with a chunk of large bedrock. It's weathering when it's breaking down. Mechanical and chemical, biotic rocks are smaller now.
I hope that was useful, for want of a better word. What we need to do now is you need to create a information sheet about weathering. And what I want you to do is to set it out a bit like this example over here. So we've got a title, weathering processes, weathering is, and then there are 4 types of weathering. For each one, you need to write down the explanation, and if you can, try and draw some little diagrams to help explain the process. Now, what's going to happen is I'm going to talk through each of them in turn. We'll start with onion skin weathering and freeze-thaw weathering, and we'll move on. And for each piece of information, for each type of weathering, you need to do the following. You need a diagram. You need to decide whether it's physical, chemical, or biological, and we'll talk about that as we go. Okay, and then at the end, we're going to think about how it affects river landscapes. So let's get started with onion skin weathering. So onion skin weathering, this is actually an example of what onion skin weathering looks like in the real world. And you can see why it's called onion skin weathering, because it does look a bit like an inside of an onion. And it basically happens, particularly in hot places, deserts, for example. And it happens because the rock is heating up and cooling down. Now, what that means is during the day, think of a desert, you can get 40, 50 degrees Celsius, and the rock is going to get hotter and hotter and hotter. And as it gets hotter, it's going to expand. But rocks are rubbish conductors. So the outside gets super, super hot, but the inside might not get very hot at all. So the outside expands a load, and then the inside doesn't. And then at night, it gets really cold in the desert. So the outside contracts a lot, but the inside doesn't. Next day, it gets really hot again. The outside expands, the inside doesn't. The outside contracts at night, the inside doesn't. And if you imagine just getting hold of something and then pulling it and contracting it and pulling it and pushing it back together, and you keep doing that, eventually the thing will break up. And it forms these sort of layers you can see here, where it's just basically had enough of being expanded and contracted and expanded and contracted, and it will just form little flakes that break off. And that is, I say, the most important type of weather in hot, dry climates. So that's our first. Now, it's called mechanical weathering. And it's mechanical weathering because it's physically things moving, getting bigger and smaller because of temperature. But anything that involves the movement, the sort of, again, expansion, contraction, physically moving, and that'll be because of the changes in temperature, is called mechanical. So this is our first type of mechanical weathering. So probably stop the video, write down what onion skin weathering is, draw a little diagram of it. Remember, the rock gets bigger during the daytime, and then contract from the at night, and that keeps going. It breaks up into this sort of onion-shaped sort of layers where it peels off. Get that explanation down. Remember, it is mechanical weathering. When you've got that done, let's go on to the next one. Okay, so now we're on to our second type of mechanical weathering. And this one forms in cold environments. Now, it's called freeze-thaw, and there's a big clue in that name. So if you look at this diagram, you can see what's happening. So first of all, you've got to have a crack, and water fills that crack. So water goes into a crack, and then at night time, it will freeze. Now, ice, okay, is less dense than water. That's because if you freeze water, it expands. So when you freeze that water in the crack, the water expands as it turns to ice, and it makes the crack a bit bigger. And that happens at night time. And then during the day, temperature goes above zero again. And what that means is the ice will melt and more water can get into the crack. And then at night time, it goes below zero again. The water freezes, the ice or the water turns to ice and expands, the crack gets bigger. Then the sun comes out the next day, it all melts again, and so on and so on and so on. Eventually, the cracks get bigger and bigger and bigger, and the rocks will break off. It's worth remembering that this is called freeze-thaw. So there are 2 places where this can't happen. It can't happen in places that never have a temperature below zero, because it would never freeze. So you couldn't freeze and you couldn't thaw. But nor can it happen in really cold places. So this doesn't happen in Antarctica a great deal because it's always freezing. So the water gets into the crack, it freezes, but then it never unfreezes. You tend to find this in places like, I don't know, Scotland or something like that, where actually you've got sub-zero temperatures at night and above zero temperatures during the day. So again, stop the video. Okay, get a diagram done. You don't need to draw all of that. Okay, 3 or 4 stages is absolutely fine. Make sure you've explained it, make sure you're clear, it's because it's about expansion and contraction, and if things are moving because of temperature, we call that mechanical weathering. When you've got that done, okay, so pause it now. When you've got that done, let's go on to the next one. Okay, so now we're on to a second type. We've looked at mechanical weathering, now we're looking at chemical weathering. And chemical weathering is really simple. Rain is naturally acidic. Okay, when water goes into the atmosphere, it reacts with carbon dioxide, and that carbon dioxide is then naturally it's made worse by pollution. Okay, so for example, if there's sulfur dioxide emitted from power stations, that will react with water to form sulfuric acid. Nitrous oxide will form nitric acids. So pollution does make this worse, but rain is naturally acidic because it reacts with carbon dioxide. And quite simply, when it rains, that acid will just dissolve away rocks. And it's particularly true, as you can see here, these are all rocks and statues and things made of limestone. And limestone is calcium carbonate, so the acid reacts with the calcium carbonate and just dissolves it. Okay, so that is the simplest form of chemical weathering. It's the one you need to know. There are others. So for example, things with iron will rust, we call that oxidation, but this is the simplest form of chemical weathering. Okay, so again, make sure you've explained it, a little diagram perhaps, H2O plus CO2 equals carbonic acid, has some rain falling down, rock dissolving, something like that, I don't know. When you've got that done, let's move on to the fourth and final one. Okay, and the fourth and final one is biological weathering. And biological weathering, as the name suggests, is animals and plants breaking up rocks. And if you have a look over here, you'll see you've got some trees here, and those trees, those roots are getting into the rock and they're going to break that rock up. Okay, so any sort of burrowing of roots or things like that will break the rocks up. It doesn't have to be plants, it can actually be animals, and that looks like some sort of, I don't know whether it's a whelk or something, cockle or something, some showy sort of thing, but you can see it's drilled a hole here where it basically lives. So it doesn't have to be sea animals, it could be rabbits, for example, rabbit burrows or badgers or anything like that, which will basically break up the soil and the rock, weakens the rock, weakens the soil, and that basically then makes the rock weaker and easier to erode or to fall down using mass movement. So that's our fourth type. That's what we call biological weathering. Again, you might want a diagram or something just to explain it, briefly explain it. When you've got that sheet done, okay, then let's go and look at the final bit. So hopefully you've now got this bit of the sheet done. It's this bit, the impact on river landscape, I just wanted to talk about before we move on and start looking at some exam questions. And actually, if we think about it, where are these rocks? These rocks are on the valleys, on the side of the valleys. And what it's doing is that weathering, breaking those rocks up. It's turning solid rock into small fragments into soil. And then those fragments and bits of soil are falling down the side or creeping down the side or slipping down the side due to mass movement into the river. And when they get into the river then washes them away, transports them away. And so this is a really important process in understanding why, particularly in an upper course of a river, you've got such steep sided slopes, because actually you've got the weathering breaking down the rocks of the valley side, mass movement bringing that, transporting that down into the river, and then the river washing it away. And that explains how you get this sort of vertical erosion, not just from the river, but from the weathering on and the mass movement on the side. That's all the theory we need to look at today. What I want to do now is have a go at a couple of exam questions. So let's have a look. So first two questions you're going to have a go at, and you can mark these yourselves, and by all means email us if you've got any questions or if you're not sure, but okay, have a go at these. So the first one is describe how a river transports its load. So it's going back over that first bit we looked at, processes, thinking about the movement. How do you get a rock to move in a river? Okay, and what we're really looking for is using some technical terms: saltation, suspension, traction, explaining those. And then the second one asks you to actually annotate these diagrams, okay, to explain how a floodplain forms. And that's thinking about what we looked at last lesson. And here we're talking about two things. We've got that sort of lateral movement, side to side movement from a meander, eroding on the outside, depositing on the inside, okay, and that's going to erode from side to side and to create that. But then also, as we looked at last lesson, you've got the river flooding, bursting its banks, depositing silt and alluvium. So there's probably 7 or 8 minutes work there, to call it 10 even. So what I want to do is stop the video, have a go at answering those questions. Okay, try and see if you can use some technical words, and then we'll have a look at what the answers are after. Okay, right, so I'll stop you there. Give yourself 10 minutes, have a go at that. Okay, well, I hope you had a good go at that. Let's have a look at question 1. Okay, so question 1 was asking, how does a river transport stuff? And basically, what we're looking for is a key term, okay, and what that key term means. So the first one is traction. And traction is when large boulders are moved along the bottom of the bed. They're in contact with the bottom of the bed, and they might be rolled, they might slide, they might drag. So 1 mark for saying traction, 1 mark for explaining what we mean by traction. Then sand, and it's mainly sand rather than pebbles, but can be pebbles sometimes, okay, is moved by saltation. And saltation is hopping. And what happens is that when the river goes ever so slightly faster, it picks a bit of sand up and carries it, and then the river slows down and that sand's deposited. And it basically hops along the bottom of the bed. And like I say, that's common for how sand moves. Finally, okay, well not finally, sorry, you've got suspension, and that's when very fine light material basically floats in the water, and that's called suspension. 1 mark for suspension, 1 mark for talking about it sort of floating in the water because it's not very heavy. And lastly, remember we talked about chemical weathering. Well, that acid rain goes up into the river, so the river will also dissolve rocks as well. And when it dissolves it, those sort of chemicals will get transported in the water, and we call that dissolved load. And again, we call that process solution. So 1 mark for each correct term, 1 mark for explaining it. So hopefully you've got 4 marks on that. And if not, get your red pen out and have a go. Okay, next, okay, we're going to look at this one. So apologies for the slight bit of formatting mistake there. So basically, anything that you write that's sort of annotated correct is going to give you a mark. So if you've got this idea it's formed by erosion and deposition, 1 mark. If you talked about how the floodplains are widened by meanders, give yourself an extra mark. If you've talked about erosion on the outside of a meander, okay, give yourself 1 mark. If you've talked about lateral erosion, give yourself a mark. And if you've talked about deposition, okay, when the river floods, give yourself a mark. If you've talked about the biggest material forming, remember to talk about the levee, give yourself a mark. And if you've talked about it over a long period of time becoming flat, give yourself a mark. So have a go at that. If you're not confident, I'm happy for you to email me and let me know what you're not sure about. Right, now we're going to move on. We're trying to do something slightly different. So actually, I'm going to ask you to have a go at this and send it to me. Now, you can send this to me by email. However, I really would prefer for you to submit this via Teams. Okay, if you can do, it makes my life a lot easier, and it also means I can give you better quality feedback. But what I want you to do is explain how a V-shaped valley forms. And I want you to think about this, and let me just draw a little diagram. Here's your V-shaped valley, and let's put the river at the bottom. I want you to think about not just the river. So, for example, what's going on up here? Okay, Think about how weathering might be breaking up the rocks on the side of the valley. Think about how mass movement, things like rock falls, soil creep, all those types of things, will then move that broken up weathered material downhill into the river. And then think about the river. Think about how the river is eroding downwards. So you've got that sort of vertical erosion as it's going down. But you've also got, he says, found in a different colour, you've also got the river transporting that weathered material and eroded material out, making it deeper. Now, to get a really good answer, I want you to use as many of these things down here as you can do. If you can get, okay, the majority of these key words are high energy. That means the river's got power, vertical erosion, it's eroding downwards, hydraulic action, the force of the water smacking into the rock and breaking bits off, mass movement, that movement of material down the side of the slope, the weathering, steep-sided, okay, the river channel, weakens, transported, gradient, abrasion, solution, valley, fast flowing. I'd put in freeze for in there, mechanical weathering. As many of those words as possible, okay, will give you the best answer. Okay, you won't need to use all of them, but the more the sort of merrier. And in terms of marking, this is what we'll be looking for. We'll be looking for you guys to be hitting excellent. Okay, and to get excellent, okay, which is 5 or 6 marks, put that into GCSE standard. We're talking like 7, 8, 9 level. What we're after, okay, is that there is sort of 4 stages. Is that you've got this idea of different things. You're talking about the river, okay. You're talking about weathering. You're talking about mass movement. You're actually naming types of weathering, types of mass movement, types of erosion. Okay, but by those 4 stages, I'm really after you mentioning erosional processes, weathering processes, mass movement, and transportation. If you can get those 4 things in there, it will be excellent. Now, like I say, if you can submit that via Teams, that's absolutely brilliant. If you can't, get it to me by an email or any other way possible, but Teams is the best way. It'd be really appreciated if you can do that. Likewise, if you've got any questions about anything on this video, okay, give me an email. I'll happily try and help you out. And if, again, you've done some really good work and you want to show that off as well, please show it to me. So I hope that's been useful. Any questions, email, but good luck, and I look forward to seeing your work. Cheers.